Okay, so here's F8. This will go faster. So they're asking you this time to find dy dx in terms of x and y. So since here they're asking us to find dy dx, they are implying, and I guess this is maybe, I don't know if this is why they call it implicit differentiation, but I just use the word implying. Maybe, I don't know, maybe that's why. So here they are implying, by asking us to find this, they are implying that that y is actually equal to y of x. All right. So dy dx means y prime of x, which implies that y is equal to y of x, which means that we're going to need to use chain rule to find some derivatives. Okay, so I'm going to replace the y's with y of x. If this was dx over dy, then I would be replacing the x's with x of y, but that's not typical. So the x's are fine, but the y's need to be replaced. So I used to have y's here. Now, oh, you can't even see, sorry. I used to have y's here. Now I'm putting y of x. Y of x. Okay. So the derivative of -4 is 0. The derivative of x to the third is 3x squared. For this derivative, we need product rule. Okay? So the derivative of x to the third is 3x squared. The y of x just comes down, plus the x to the third just comes down. What's the derivative of y of x? Y prime of x minus. Then for this derivative, we need chain rule. So y of x is the inside, blank to the third is the outside. Y prime of x, 3 blank squared, and the y of x goes back in there. So the derivative of that term is 3 y prime of x, y of x squared. Okay, now I'm going to drop the function notation. So first in this line, I replaced the y's with y of x. Then I took the derivative. Now I'm going to go back. Wherever I had a y of x, I'm going to put a y instead, because it's just way easier to work with that. So this is 3x squared y plus x to the third y prime minus 3y prime y squared. Then you've got to solve for y prime. So I need, and you know what? Okay, what we've got to do, okay, you know what? I'm gonna flip this equation. So because I already have all the y prime terms over here on the right side. And I would like them, I guess I'd like them on the left. Sorry. I just have 2 ways I could do this, and I'm trying to think. Oh my gosh. All right. Well, you know what I'm going to do? I'm not going to flip the equation. But so I want, and actually, guys, what I'm about to do is not the only way to approach this, but I just got to pick a way for teaching. The y prime terms, I need them on the left, and I need the non-y prime terms on the right. So I'm going to subtract this one from both sides to put it over here. And I'm going to subtract this one from both sides to get it over there. And I'm going to add this one to both sides to also get it over there. So I'm going to end up having negative x to the third y prime plus 3y prime y squared equals 3x squared y minus 3x squared. Okay, so I've separated the y prime terms from the non-y prime terms. Then I've got to factor out a y prime. Okay, and then the very last step, you just divide both sides by the parentheses to get rid of it. So I'll just do that like right here. And I'll convert to, it's not wrong if you don't convert back to Leibniz notation, but I think all of my solutions, I have Leibniz notation, so I'll convert back. Okay, now this one. So again, y equals y of x. Okay, that is what is implied. Okay, this is called implicit differentiation, possibly for that reason. So, so here, I'm gonna, wherever I saw a y, I'm going to instead put a y of x. Oh, this one's not bad at all. I don't even really need chain rule here. All right, now I'm taking the derivative of everything. So the derivative of this term, guys, the -5 is just a coefficient. A coefficient is a number that is just a regular number with no variable that's being multiplied. A lot of times a coefficient is called a constant multiple. So coefficients or constant multiples just come down. What's the derivative of y of x? Y prime of x plus. For the derivative of this term, we need product rule. So the derivative of, because it's a product, the derivative of x is 1, and then you bring down y of x plus. X comes down, derivative of y of x is y prime of x. So in this phase, guys, you're using product rule. Okay, this is a normal derivative, so -3 equals derivative of a constant is 0. Okay, now let me drop the function notation now. So this is -5 y prime plus y plus x y prime. Alrighty, so here are the y prime terms. So I want them all by themselves. So I've got to subtract this y from both sides and add this 3 to both sides. So -5 y prime plus x y prime equals, you could do -y plus 3 also. Then I'm going to factor out the y prime. And then I will divide both sides by the parentheses, and then I end up with dy dx equals 3 minus y. Okay, guys.